We all came from the sea. And it is an interesting biological fact that all of us have in our veins the exact same percentage of salt in our blood that exists in the ocean. And therefore, we have salt in our blood, in our sweat, in our tears. We are tied to the ocean. And when we go back to the sea, whether it is to sail or to watch it, we are going back from whence we came.
We are born into a world of frantic noise and commotion. But we start out floating serenely in an amniotic water world, bathed in stillness. To be reborn, we can immerse in Mother Nature's amniotic fluid, the ocean. There, when calm prevails, we submerge in soothing seawater like a newborn returning to the womb. This vast ocean is our evolutionary home and a liquid reminder of our journey as a species. The shoreline represents our birth and our transition to an air-breathing world. It marks our psychological passage from water to land, the same boundary that marked our species' evolutionary succession from pre-hominid ancestors emerging from the ocean. The dreamy seascapes that invite us back to primeval existence once enticed ancient explorers to sail beyond the far horizon in search of new worlds. Like early sailors, we too are seeking to discover the mysteries of the ocean, including its vital role in the creation of life on this planet. As with life, the ocean can change from calm to chaos in a matter of seconds. It can become more turbulent than life itself. So we cherish the calm and stay close to the seashore and to the soft sand that warms our feet on a sunny day. The ocean is our planetary heart. It is to nature what our mother's gift of birth was to us, a passage into life, or more accurately, a passage into the web of life, a web of wonder that adds beauty and life-sustaining services for the entire biosphere. Many people have argued that our planet should have been named Ocean. But human respiratory systems ensure that our allegiance is to land. So perhaps we should have compromised by naming our planet Island. Islands remind us of the ubiquitous presence of salt water in our bodies and in our terrestrial lives. More importantly, islands dazzle us with the wonder and the splendor we behold when deep green land meets azure ocean. In the Pacific Island Republic of Palau lies a slender lagoon of pale turquoise reflecting a bottom of white limestone mud. It's called the Milky Way. The shimmering ocean that surrounds it invites human visitors to marvel at Palau's sublime beauty. It is an oceanic symbol of aesthetic power and ecological wealth, not to mention a symbol of what is at stake in the relentless pursuit of human development and domination. For the past 25 years, I've made an annual visit to Palau in order to study its spectacular reefs and to learn how marine ecosystems can be better protected from overfishing, climate change, and various forms of pollution. Palauans are among the world's leaders in responding to these challenges, and it's no wonder. They stand to lose a lot in the Anthropocene, most of it due to development pressures and environmental threats from abroad. Beginning in the year 2000, my visits to Palau have been accompanied by an expedition team of 12 college students selected from the University of Redlands in California. Members of the expedition study this island republic and its people as a microcosm of Earth's oceanic wealth and environmental vulnerability. Because of its small scale, Palau's ecology and economy can be closely observed in ways that help students make important connections between things like coral, commerce, and culture. For example, students analyze how carbon emissions threaten Palau's marine ecosystems, its tourism-based economy, and its changing climate. Basically, Palau is small enough to be comprehensible as a system of interacting systems. In this episode, we will scale up from Palau to the global ocean in order to examine the Anthropocene's impact on marine life everywhere. Although we started by celebrating the magnificence of this ethereal ocean, be prepared for some bad news. The health of the ocean is rapidly declining, and we need to understand why before we can restore it to vitality. My academic colleagues tell me to avoid depressing you with a long list of problems. The truth is that becoming informed about the interlocking nature of those problems is a necessary first step in solving them. If you want to become truly hopeful about the future, there is no better way than to recognize that the problems we face are eminently solvable by informed people of goodwill, whether they involve the ocean, the climate, society, or human relationships. Remember that as we consider today's threats to ocean health. But lest you assume that the rest of this class session is all about gloom and doom, rest assured that I have interwoven scenes of ocean bliss to remind you of how wonderful and precious the ocean still is, and why it is far too valuable to be handed over to the greedy architects of the Anthropocene. The fact is, humanity's impact on the ocean is no longer local or short-lived. Rich and powerful members of our species have set in motion global changes that will last for many centuries, if not millennia or more. Hard as it may be to grasp, humans are now shaping the Earth and its ocean, and in the process, threatening the biosphere that we and our fellow creatures inhabit. Many of the threats we generate are carried to distant shores by an ocean conveyor belt of currents. Others are introduced by ships, tourists, polluted watersheds, and atmospheric fallout. Tourists, for example, can pose a threat to marine life merely by wearing ordinary sunscreens, or by carelessly walking on live coral. It seems that most people are unaware of the accumulating environmental impacts imposed by their lifestyles, and the irreplaceable natural wealth that is lost as a result. The tremendous beauty and living treasures that the Anthropocene endangers are on full display in Palau. Its most famous landmark is Jellyfish Lake, one of more than 70 marine lakes found in these islands. Its fame arises from millions of golden mystigious jellyfish that occupy its protected saltwater habitat. Because these jellies are found in only about 5 of Palau's landlocked lakes, they have evolved in isolation from natural predators, thereby losing any significant ability to sting. The golden jellyfish are both hauntingly beautiful and exquisitely strange. Brainless, bloodless, and boundless in energy, these simple invertebrates are made up almost entirely of water. Moving by jet propulsion, their translucent bells pump both day and night in a lifelong quest to follow the sun. They pulse until they die. Vast armadas of these gelatinous cruisers begin each day tracking the sun's first rays, migrating across the lake so that symbiotic algae living within their tissue can better capture solar energy needed for photosynthesis. Avoiding shadows like children afraid of the dark, they bask in midday sunlight, harvesting energy until the shadows begin to lengthen. Then they reverse course, returning to the other side of the lake for a night of vertical migration up and down the water column. Places like this remind us of how astonishingly beautiful life can be, and how fragile is the source of that beauty. Life on Earth is a circle of relationships that we sever at our peril. We may not need the golden mystigius for our economic welfare, but we do need them for our humanity. By protecting these creatures, we are protecting something noble in ourselves and securing our place in the great circle of life. Covering 71% of the Earth's surface and averaging 2.5 miles in depth, the ocean is by far the largest three-dimensional habitat zone on Earth, representing more than 95% of the planet's total life space. Many of our favorite monsters and feared predators reside here, and most of its habitats lie in perpetual darkness. All of the Earth's biggest mountains, valleys, volcanoes, and canyons can be found in one or more of the 5 major basins that form the singular world ocean. The abyssal plain alone covers more than half of the Earth's surface, nearly all of it more than 3,000 meters underwater. Although the ocean is heavily affected by climate change and other anthropogenic threats, it is also true that the ocean functions in many ways to moderate or buffer many of the worst effects of human-driven disruption. Not only does it moderate temperature around the world, but it also serves as a climate shock absorber because it absorbs about 1/4 to 1/3 of all atmospheric CO2 emissions. Although a very slow process, carbon uptake by deep ocean layers accounts for hundreds of billions of tons of CO2 removal from the atmosphere over periods of 2 or more centuries. Serious scientific questions have arisen about whether the oceans will be able to keep pace with anthropogenic emissions of carbon. The seas may become saturated before long and begin to release more CO2 to the atmosphere than they absorb. Moreover, even if this does not happen for many decades, the increase in CO2 absorbed will add to the problem of ocean acidification by producing more carbonic acid. The acid problem, as we shall see, may be as threatening to the ocean as climate change itself. Ultimately, many of the oceanic changes associated with the Anthropocene can best be understood as risky chemical experiments in Earth system resilience. Degradation of ocean systems inevitably translates into degradation of atmospheric and other systems as well. If we have learned anything that transcends the Anthropocene, it is that Earth systems are tightly coupled and often interact in ways that science only dimly understands. Many people falsely assume that the ocean is simply too big to suffer any lasting or widespread damage from human activities. For most of human civilization, it was an article of faith that people could never exhaust the fish and other resources of the ocean, seriously pollute it, or interfere substantially in any of its global energy flows and biogeochemical cycles. How times have changed. Today, the ocean faces at least 8 types of major environmental threats. As previously noted, changes in climate and ocean systems are massively interconnected. Oceanic climate threats include warming water, sea level rise, coral bleaching, and extreme weather events, such as more intense typhoons and hurricanes. By altering the depth and latitude of marine habitats, warming waters are forcing many species to move deeper or toward the poles in order to maintain their optimal environment. In the process, tightly connected food webs are being disrupted, along with everything from whale migrations to polar bear predation. Researchers have discovered that climate impacts are displacing marine species from their habitats nearly twice as often as occurs with species found on land. Weak solutions of carbonic acid threaten many shellfish and other creatures with hard parts, such as reef-building corals, and almost every other form of marine life that uses calcium carbonate for support or skeletal structure. These creatures are especially vulnerable at juvenile stages of development. Today's ocean is already a third more acidic than it was 2 centuries ago. Almost all of that increase is attributed to CO2 emissions from the burning of fossil fuels. The effect on food webs and reproduction rates will be potentially devastating. The world's 4.6 million commercial fishing vessels are chasing fewer and fewer fish, while drawing down the reproductive capacities of many fisheries to regenerate. Overfishing has decimated an estimated 90% of the ocean's large predators. Wasteful fishing, in the form of bycatch, results in a third or more of all fish caught being unintended, unwanted, non-target species. Many nations heavily subsidize this destructive race to the bottom. Meanwhile, more than 3.5 billion people depend on the sea for much of their protein. Chemical pollution from oil spills, pesticides, heavy metals, sewage, fertilizers, detergents, and persistent organic pollutants, such as PCBs, continues to spread through most marine ecosystems. about 80% of it originates on land. In addition to plastics, which are treated in a separate threat category, there are other types of pollution that merit special concern. For example, noise pollution threatens whales, dolphins, and porpoises. And harmful algal blooms caused by fertilizer use and climate-induced warming can produce biotoxins that threaten people and marine life. Oxygen depletion from coastal runoff of fertilizers and other forms of nutrient enrichment have increased the global number of seasonal dead zones from about 10 documented cases in 1960 to over 500 today. The worst dead zones, those with zero oxygen, have quadrupled during the past 70 years. The causes are well understood. Nitrogen, phosphorus, and related compounds that are being used excessively in agriculture and industry, along with sewage pollution, promote massive algae blooms that deplete the oxygen in the water when they die and are decomposed. A warming climate will exacerbate the problem. Even worse, microbes that thrive in low oxygen areas will produce more nitrous oxide, a powerful greenhouse gas that is much more potent than CO2, driving positive feedback loops. Too many of us accept the trashing of the ocean as collateral damage from living in a consumer, throwaway society. Even the most remote islands now collect wave-washed piles of human trash, especially plastics. Each year, about 18 billion pounds of plastic enters the ocean, mostly from coastal runoff. Some of it will take hundreds of years to decompose, and some of it will be consumed by marine life and seabirds, causing slow starvation as their guts fill with mistaken food that contains no nutrients, only potentially toxic chemicals. Adding to the challenge is the rise of microplastics, which invisibly flow worldwide through the ocean while carrying persistent organic pollutants that increasingly contaminate the marine food web. Habitat destruction, especially of benthic sea bottom habitats, is mostly caused by bottom trawlers that scrape the seafloor in ways that are analogous to clear-cutting forest. As amazing as it sounds, much more area of the ocean bottom has been cleared by these fishing techniques than has been cleared on land by timber operations. Among the precious life forms being destroyed by bottom trawling are deep-sea cold-water corals. In addition to killing many types of non-targeted fish and other marine life, the trawlers scrape habitat away, leaving benthic deserts in their wake. The final impact we will examine involves the successful spread of alien life into areas where it displaces native species, sometimes because it lacks the usual predators found in its home range. Most of this alien life is inadvertently introduced in the exchange of ballast water from cargo ships. Ships pump in ballast water from the ocean for stable navigation, and then pump it out in distant ports when taking on large amounts of oil or other cargo. In the ballast water are small marine hitchhikers, usually creatures in their infant or larval stage, which are then inadvertently introduced to new habitats along the shipping routes when the water is pumped back to the sea. Some invasives are intentionally introduced. Some detach from hulls of ships or other floating surfaces, and some escape or are set free from aquariums and storm-tossed containers. These lionfish are a good example of the latter pathway. They have caused a very destructive invasion in the Atlantic and Caribbean. Native to the Indo-Pacific, lionfish are voracious eaters of more than 50 other species, especially juvenile reef fish. Now established in most of the Caribbean, they are spreading into the Gulf of Mexico and along the Atlantic coast of South America. A serious threat to coral reef ecosystems, their venomous spines make them a difficult invader to defeat. However, they are merely one of many invasive populations that are growing along the coastlines of more than 150 countries and territories. When we survey the ocean's surface, everything appears to be flourishing, or at least manageable. But as we have seen, the living ocean of the Anthropocene is facing ecological collapse. Maybe not in this century, but long before humans gain enough control over Earth's systems to prevent it. Long before marine mammals are safe from hunters and fishing nets. Our immersions in the deep are encounters with a world that is not yet predominantly the product of human thought and design. That is why many of us yearn for distant shorelines untouched by plastic and crowds of people. Places that are still home to food webs formed during the Cambrian explosion more than 500 million years ago. The peril that waits beneath the surface is not sharks or venomous fish. It is the growing human footprint that daily disfigures the face of the ocean, this planet's largest and most precious jewel. Underwater, we feel like awkward aliens with bubble machines on our backs. But what we experience is a wellspring of wonder that inspires us to cherish the diversity and beauty of this wild ocean. If only we could comprehend how many spectacular life forms have been lost in the course of so-called human progress. Fortunately, enough beauty and diversity remain to stiffen our resolve to protect and restore the ocean. Seduced by the splendor of a coral reef, perhaps we'll discover that the beauty inside us depends on preserving the beauty outside. Or perhaps, like a kelp forest, we'll discover that the roots of our common existence are anchored in the sea, reaching for the sun in a world of magnificent interdependence. How hard can it be to fall in love with such amazing places and creatures? The answer to that question may well determine the fate of the Anthropocene.